Right, this is beautiful again. We want to get to this type of work. Good afternoon, good evening, good morning, wherever you're getting me from. This is the area for Pentagon, and Pentagon simply comes from a family of polygons. So this comes from a family of polygons, and anytime we are talking about polygons, we're simply talking about this is a Greek word. It's, it comes it comes from the Greek, and we need to know that it is divided into two. So you can have the word poly, which simply means sides and many sides, or simply many angles. So the word poly simply means sides or angles, and of course it means many. So it is just simply a meaning of many. Then gons, this means sides. Gons means many, so it can be many sides or many angles. So anytime we're talking about a pentagon, penta is the same Greek word that means five. Penta simply means five. So if we are talking about the pentagon, then it means a five-sided. The word is gon for sided. Penta means five. Now, a polygon, just as a family, means that we are talking about those um, figures, those figures whose shapes uh, are comprised of at least three or more sides, three or more. So if we're talking about three or more sided figures, then we are talking about polygons. So polygons are simply three or more sided figures. So we have three, which we of course refer to as a triangle. We have four, of course, four. These are several. We have squares, we have rectangles, we can have trapeziums, and so on and so forth. Five, we have said this is pentagon, pentagon for five. Six, of course, you can guess, you can make a clever guess. Six is simply hexagon. So that means a six-sided figure. And then we have seven. Seven is hepta. Seven is heptagon. So heptagon is simply a seven-sided figure. So for those figures that have seven sides, that is heptagon. Eight is octagon. Octagon. So octagon for eight. Octa, I said, means eight, and then gon for sided or sides. Nine is referred to as nonagon. So nonagon is a nine-sided figure, and then 10-sided figure. 10 is known as decagon. So we have three, four, which are several. We have five pentagon, and so on and so forth. So right now we just need to lower ourselves down to looking at the area. So this comes under the strand called measurements. So this, we have area, we talk about volume, we talk about speed, we talk about distance, we talk about weight, we talk about velocity, and so on and so forth. So here we need to look at the area. Area of a pentagon is quite simple. Now, how do you get? You will realize that we can divide this pentagon into a number of triangles from the center. So you will realize that the number of sides is equivalent to the number of triangles that we can get here. So if we have triangles, if we have to divide this into triangles, let's say we divide this from the vertex to the center, that way. So we join all vertices to the center. We do it that way comfortably. Say we join up to there. We join also this one here. That way. Again, we join that way. So these sides are equal. The sides are equal. The sides are equal. So because they are 5, we said it is referred to as pentagon. Now you can count for yourself. You can count how many triangles are there. You will realize that we have 1, 2, 3, 4, 5. There are 5. So for pentagon, 5-sided, and therefore it results into also 5 triangles. So how do we come up with area of the same? Quite easy. Quite easy. Here we just get the area of 1, and then we shall multiply by 5 because they are 5. So we get the area of 1 triangle, then replicate it 5 times because they are 5 in number. So in this case, how do we get the area of triangle? So area of a triangle is equally very important. Area of a triangle. What is the formula? You can make a clever guess. The formula is simply area is given by a half. You multiply by, in this case, let's say we shall be given the sides, multiply by base times height. There are several formulas, like a half AB sine theta. That one is beyond a bit your level, and therefore you don't need to look at that. So we can have, I said, a half A times B times sine of theta. But this one, we're not talking about that right now. So we are just simply lowering ourselves to what we are supposed to know at our level. So at this level, let's say we want to get the area of this smaller triangle here, this one here. We drop a perpendicular from the center. We drop a perpendicular to that other line. Now let's say this is a pentagon of side 6 centimeters. 6 centimeters. So we have 6. 6 is replicated everywhere because all the sides are equal. Now, let's say from the center to the vertex. This one gives us, let's say, maybe 5 centimeters in this case. So we have 5 centimeters from the vertex. And remember, because it is a pentagon, all other triangles are equal. So because that is the case, we have said, we are going to get now the area of this, then replicate it 5 times. So multiply by 5 because there are 5 triangles in number. So here we shall have, therefore, our area is given by, okay, all right. Because we have dropped a perpendicular from the center to this other line, the margin of our pentagon, it means it's cutting, dissecting this line into 2 equal halves. So in this case, we are going to have here 3 centimeters and also here 3 centimeters. So we can calculate the height, because we know the base of our triangle here is a 6. So we have this triangle. In other words, this is the triangle that we are having. We can do it that way, and then it will give us easy time, because from here up to the end is 6 centimeters. So this is 3 centimeters. And this one here is 5. So we have here 5 centimeters. So up here 5 centimeters. So because this is 3 or this is 3 centimeters, we can get the height. How do we get the height? The height will be just be using Pythagoras theorem formula. We shall say AB squared. This squared multiplied by this added to this squared will give us the hypotenuse. The base squared multiplied by the height squared. Base squared added to the square of the height will give us hypotenuse. So in this case, if we take the square root, therefore, the square root of 3 squared, sorry, not really, the square root of 5 squared. Now maybe somebody is feeling confused here. We said for us to get this height, we shall have, we said a squared plus b squared is equals to c squared. Now, our C here is this 5. Okay? So for us to have this one here, therefore, this is our C. So either A or B should be taken to the other side. So this is our A, this is our B. Let's say so. So for us to have B, we shall have now B squared is given by C squared minus, this one is taken to the other side, which is A squared. Now what is our for us to get our B? Our B is simply we take the square root, both sides. So the square root of that B will give us the square root of C squared minus A squared. I think up to there, we can now successfully and comfortably work out that height. So in this case, we have a C squared minus a squared. C squared minus a squared, and we're getting the square root. So in this case, we have the square root. So our height will give us the square root of 5 squared minus 3 squared. So this is the square root. Yes, our height will be the square root of, that is 25 minus 9. And what do you get? What do you get? Remember, they are centimeters. So we have this, you'll get 16. The square root of 16 is 4. So our height is 4 centimeters. So this is 4 centimeters. Now next, what do? Next, you've already gotten the dimensions that are needed for us to slot into our formula, for us to comfortably work out the area. So our area now, in this case, area will be given by, of course, a half now multiplied by our base, which is 6. This one here, multiplied by our height, which is 4. Okay, so we have that. Next we have our half. We now work it out. 2 here, 1. Okay, 2 here is 3. Then we have now 3 centimeters multiplied by 4 centimeters. So this is 3 centimeters multiplied by 4 centimeters, which gives us, that will give us 12 square. Centimeter and a centimeter is squared, so it is square centimeter. Now remember, this is now the area of this very particular triangle. And how many are they? There are 5. So we shall simply have now 12 square centimeters, multiply this by 5. This will give us 60 square centimeters. So this now qualifies to be termed as the area of this polygon, because we shall have taken the area of this and then multiplied 5 times, because there are 5. So what we are learning is, number 1, is that the number of sides dictates the number of triangles that we can get if we have to divide the pentagon from the center. 2, we have said for us to get the area of the pentagon, we are simply going to get the area of one triangle and then replicate 5 times, or simply multiply by 5, because there are 5 triangles. So for you to keep on remembering that, it needs you to get down to practice, and therefore you can pause and try to work out this one here. Yes, we can say, sorry about that, we can say now, work out the area of a pentagon whose sides, let's say, whose sides are, let's say, like in this case, we have maybe 8 centimeters, and distance from the center, to distance from the center to the vertex, any of the vertices, is, that distance is, let's say, 10 centimeters. So you can work out that and then try to see if you can get the correct answer. Continue subscribing, continue welcoming friends and inviting them to dine with us. This is great knowledge that we cannot afford to dine on it alone. Shalom.